Good evening, children.
Good evening, ma'am.
Good evening, ma'am. Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening, children. Yeah. So we have a little more to complete congruent triangles. So this one, if two isosceles triangles have a common base, if two isosceles triangles have a common base. So what do you see here? What do you see here? The common base is BC. And these are the two isosceles triangles, ABC and DBC. Here also we have the common base BC and ABC. ABC is one isosceles triangle and DBC is the other isosceles triangle. So the difference is that in this figure, the two isosceles triangles lie on the opposite sides of the common base BC. In this figure, the two isosceles triangles ABC and DBC lie on the opposite sides of the common base BC. In this figure, the two isosceles triangles ABC and DBC lie on the same side of the common base BC. So you can also think, why not draw like this? This is the common base. Why can't we draw it like this? Yeah, you can also draw it like this below. On the same side of the common base BC. Okay, so you can also draw it like this. BC is the common base. So DBC, ABC, like this. Below also you can draw. So you can say that why not draw like this, like sideways like this. This also you can draw. So see. So these are the only two possible things, that is on the same side and opposite side. So it's a representation. This one is on the opposite sides, this one on the same sides. So you can rotate this figure, no? You can rotate this figure and you can draw it in any ways. Okay. So the two things are when there's a common base, there are two isosceles triangles, and when there's a common base, the thing is we have two cases. The two isosceles triangles can be drawn on the same side of the common base BC or on the opposite sides of the common base BC. So this represents on the opposite sides of BC and this one on the same side of BC. Then let's continue. So when we say isosceles triangles and this is the common base, these are the equal sides. These are the equal sides. And here this side is equal to this side is equal to this side. Then the line segment joining their vertices. So the vertex of ABC is A, and the vertex of DBC, the vertex of the triangle DBC is D. So this is the line segment joining their vertices. AD is the line segment joining their vertices. AD is the line segment joining their vertices because A is the vertex of the triangle ABC, D is the vertex of the triangle DBC. So AD is the line segment joining their vertices. We need to prove that the line segment joining their vertices bisects the common base. This is the common base. BC is the common base. Bisects the common base. That is, you should prove that BE is equal to EC. Bisects the common base at right angles. So you must also prove that angle 3 is 90 degrees, which means angle 4 is also 90 degrees. So what you have to prove is that AD bisects BC. That is, BE is equal to EC. That we'll have to prove. And also angle 3, angle 4 is 90 degrees. These are the two things which you have to prove. We are given two isosceles triangles. And you can see it here also. This is the vertex A of triangle ABC. Am I audible, children?
Yes.
Okay. All right. So in this figure, again, ABC and DBC are the two isosceles triangles. A and D are the vertices, and AD is the line segment. AD is the line segment joining the vertices. But I think there's a word missing here. So let me change the question. It is AD or AD produced. Okay, it is AD or AD produced. So see here, AD, here you can see that AD bisects, meaning here you can see that AD cuts BC. But here when you join AD, it doesn't meet BC at all. Then how can you prove that B is equal to EC and angle 3 is equal to angle 4? 90 degrees. So here AD produced meets BC. See, the difference is here AD meets BC. But here AD, when you join AD, it does not meet BC. AD produced meets BC at E. You have to prove that B is equal to EC and angle 3, angle 4 is equal to 90 degrees. Am I clear, children, with what is given?
Yes, ma'am.
Yes, ma'am.
All right. All right, children. So this is what we have seen in NCERT. But in NCERT, this figure was given to us directly. This figure was given to us directly, and the description was also different. The description was also different. That is, it was something like that, there is a line segment BC and the points A and D lie on the opposite sides of BC, and they're equidistant from the ends of the line segment BC. They're equidistant from the ends of the line segment BC. So something like that, okay? So we have a line segment BC. There's a point A and there's a point D that lies on either sides of the line segment BC. And it was given that A is equidistant from the ends of B and C, the ends of the line segment BC. A is equidistant from the ends of the line segment BC. That means AB is equal to AC. And D is also equidistant from the ends of the line segment BC. So DB is equal to DC. So like this, the description was different and the figure was also given to you. So for the same figure, see, you can have a description like this also. Okay, so then you'll have to, take both the cases, but you name it so that one proof will satisfy both. You name the triangle. See, you should watch it and understand. See the two figures, how we have marked. So we have marked so that, this proof holds good for both the figures. You don't have to write one proof for this figure and another proof for this figure. No, it is this proof for both the figures. If you read this and look at these figures, this information will hold good for both the figures. Yeah. So how to prove, we already know, children. How to prove this, we have already seen from NCERT. It's the same proof. It's the same proof. The proof is the same. What you've learned in NCERT, it's an example question in NCERT. Same proof. But just that I wanted to talk about this because the information, is given a different way, and you can take, because the diagram is not given, you should take both the cases. But in NCERT, this figure is given. So you don't have to consider this case because this figure is given. So you don't have to consider this case. But when you have the statement like this, you have to consider both the triangles, meaning both the figures. All right, the proof is the same. So let me just read this given for you. Triangle ABC and triangle DBC. ABC and DBC with common base BC. Okay, we are given triangle ABC and DBC with common base BC. Yeah. And then what else? AB is equal to AC in triangle ABC. AB is equal to AC in triangle ABC. Yeah. And DB is equal to DC in triangle DBC. DB is equal to DC in triangle DBC. See the same information holds good for this triangle, this figure also. AB is equal to AC, DB is equal to DC. AD or AD produced. So AD is in this figure, AD. See, you read it like this. You should read it like this. Okay. You read it like this. AD meets BC at E in this figure. AD meets BC at E in this figure. Now, take away this AD. Take away. AD produced meets BC at E. Yeah, AD produced meets BC at E. So AD is for the first figure. AD produced is for the second figure. So AD or AD produced meets BC at E. See, meets BC at E. Meets BC at E. Yeah. we have to prove that B is equal to EC. Angle AEB, AEC 90 degrees. This is AEB. See here, this is the AEB. AEC, AEC 90 degrees. The proof is the same. All right, children?
Yes.
Yes, ma'am.
Yes,
All
ma'am.
right. All right, children. Now tell me which is the other one which we have to discuss. I don't know. Only this, is it? Are we done with others? You have completed writing all this in your book because I had shared all the pictures. Don't remember what all I mentioned the other day? Oh, I think this one. Yeah, this one. This we already discussed. These are all very simple and we discussed this one also. This is important. Yeah, I finished this. Okay, children. So only this one. Yeah, this one. Okay, in a right angled triangle, one acute angle is double the other. In a right angled triangle, right angled triangle, right angled triangle, one acute angle is double the other. So that means if one acute angle is x, the other one is 2x. One acute angle is double the other. Because this is 90 degrees. These are the two acute angles. These are the two acute angles. One is double the other. Prove that the hypotenuse is double the smallest side. Prove. Oh, this proof will you have? I don't know because you don't have inequalities, right? Okay, fine. Okay, so prove that the hypotenuse is double the smallest side. So now the smallest side, see here, the smallest angle is this one. The smallest angle, am I audible, children?
Yes, ma'am.
Yes, ma'am.
Yeah, the smallest side is the side opposite to the smallest angle. Okay, well, you have not learned that because we don't have inequalities in the syllabus this year. Okay, so just take this one alone. Okay, which is the smallest side here? The side opposite to the smallest angle is the smallest side. See here, which is the greatest angle, 90 degrees. So the side opposite to that is the longest side. In a triangle, the side opposite to the smallest angle is the smallest side. The side opposite to the greatest angle is the longest side. That is why in a right triangle, we say that the hypotenuse is the longest side because the greatest angle is 90 degrees. In a right triangle, there is no angle bigger than 90 degrees. So since 90 degrees is the biggest angle, the longest side is the side opposite to 90 degrees. Right on? Yeah, please write on this, children.
Completed, ma'am.
Yeah. I'll let you. So we have to prove that the hypotenuse is double the smallest side. We know that the hypotenuse is the longest side. So now we have to identify the smallest side. So the side opposite to the smallest angle is the smallest side. The side opposite to the smallest angle is the smallest side. So in the right triangle, see here, in the right triangle, let's call it ABC. Okay, right triangle ABC, right angle at B. Okay, so let's say that this angle is X and this is 2X. Okay, that is one angle is double the other. So if this is X, the other one is double it, 2X. So now, which is the longest side opposite to the right angle? This is the longest side. And which is the smallest angle? Obviously X. Because this is the longest angle, sorry, the greatest angle, and between X and 2X, X is small. So that means X is the smallest angle. So opposite to that side, sorry. So opposite to the smallest angle is the side BC. So BC is the smallest side. So we have to prove that the longest side AC is double the smallest side BC. AC is equal to twice BC is what we have to prove. The hypotenuse is double the smallest side, which is the hypotenuse, the longest side. So the longest side is AC or the hypotenuse. You should prove that it is twice the smallest side BC. How do we know that BC is the smallest side? Because X is the smallest angle in this triangle. So opposite to that is BC. Opposite to that is BC, and that is the smallest side. So this is what we have to prove. AC is equal to twice BC is what we have to prove. Yeah, children, I just give you some 3 minutes. Just go through the proof. It's okay. You may not be able to understand why all this is happening, but just have an idea about the proof. I'm right here. Just read through. I'll give you 3 minutes. Just read through the proof. Thank you, children. And sorry, I just got a phone call. I had to attend that. Let's continue. Yeah. So what are we given here? We're given a right triangle ABC, or we have taken a right triangle ABC. Based on this information, we have named the triangle ABC. Okay, right angle at B. So this is what you first have. Take a right triangle ABC, right angle at B. It can be right angle depending on how you name it, So if you name it like this, it need not be right angle at B. If you name it like ABC like this, then it's right angle at A. So it depends on how you name the triangle. So by this figure here, ABC is a right angle at B. Okay. And one angle is double the other. I have taken this angle as X and this angle as 2X, which means by my marking BCA, this angle BCA is twice this angle BAC. This angle BCA is twice this angle BAC. See, you can just mark how much is BCA? 2X. And what about BAC? X. See here, twice X, 2X. We have to take a right triangle, and then you should mark off 90 degrees is there in a right triangle. Then one angle is X, the other angle is 2X, because one angle is double the other. So I have taken this as X and this as 2X. That's what I've mentioned here in given. That's what I've mentioned here in given. One angle is double the other. And what is that we have to prove? We will have to prove that the longest side AC is double the shortest side. Now, which is the shortest side? This is the smallest angle. So opposite to that is the shortest side. So we'll have to prove that this longest side AC is twice the shortest side BC. Okay. So again, to prove this result, we are going to, take the help of a construction. We are going to produce CB. We are going to produce CB to a point D, such that CB is equal to DB. CB is equal to DB. See, that is possible. See, when you have, I've told you, construction is something which is possible. So see here, and which is true. Now, ABC, you have a triangle ABC. It is possible to produce CB. Is it difficult? If you produce it, you will always get this line. You will always get this line only when you produce it. It's not that there are different lines possible and I'm selecting this one. No. When you produce CB, it's always going to be like this. And we have to produce CB to a point D, such that CB is equal to DB. So you can produce it to any extent. You can produce CB to any extent. But you produce CB to a point D such that this length, supposing this is say 4 centimeters, BD is also 4 centimeters. So you produce CB to a point D such that CB is equal to DB. CB is equal to DB. CB is equal to DB. Just a second, children. Join per mudida illiya. All right. So we have to produce CB to a point D such that CB is equal to DB. Okay. So that is possible. That is possible. A, B, C. Okay, so to a point D such that DB is equal to CB. That's possible. And then it's also possible to join AD. So join AD. So like this, we get another triangle. We get another triangle like this. We get another triangle like this. So produce CB to a point D such that CB is equal to DB, and then join AD. Join AD. Now see the proof. So in the proof, we are going to show that these two triangles are congruent to each other. We are going to show that these two triangles are congruent to each other. So information, simple. This is the common side. This is 90. So if this is 90, this also will be 90 because linear pair, no, it is 180. This is a right triangle. This triangle is a right triangle. So we know that this is 90. We know that this is 90. And when you produce it, it's a straight line. So linear pair, this also will be 90. So angle 1 is equal to angle 2 is equal to 90 degrees. And then by construction, this side is equal to this side. This side of this triangle is equal to this side of this triangle by construction. So the two triangles are congruent to each other by RHS congruence rule. How RHS? Not RHS. It's SAS. Sorry. Not RHS. It's SAS. It's a mistake. So by SAS congruence rule. So see here, two sides and the included angle. Two sides and the included angle. SAS. It's not RHS, children. Open your notebook. Correct that. Please correct that. Okay, I hope it's done. Okay, so this is by SAS rule. SAS congruence rule. The two triangles are congruent to each other. So CPCT. Now, what to mark? How do you know that we have to take this by CPCT? I'll let you know at the end of the proof. So CPCT, CAB is equal to DAB, which is CAB, this angle CAB is equal to this angle DAB. That means that if this is X, this is also X. So this angle is 2X. See, we have 2X here, no? We want to get 2X, somewhere else also we want to get 2X. That's the idea. We have 2X here. Why you will understand now further. We have 2X here, no? So somehow we want to get another angle also as 2X. Somehow we want to get another angle also as 2X. So we show that, so we say that these two angles are equal by CPCT. So this is X. And if these two angles are equal, if this is X, this is also X. So this whole angle is 2X. This whole angle is 2X. This whole angle. So that means in the whole triangle, when you look at the whole triangle ADC, when you look at the whole triangle ADC, we have 2X here and we have 2X here. So that is the idea. That's why we want to get another angle as 2X. Okay, so which is why we say this angle is equal to this angle CPCT. And since this is X, this is also X. That's what you see here. So we prove that the two triangles are congruent to each other by SAS rule. And CPCT, this angle is equal to this angle. So if these two angles are equal, XX. So the whole angle DAC is equal to 2X. That's what I've written here. The whole angle DAC is equal to 2X. Also, the hypotenuse AC is equal to the hypotenuse AD CPCT. The hypotenuse AC is equal to the hypotenuse AD CPCT. Is it fine so far, children? Because the rest of it is easy. Is it fine so far?
Yes, ma'am.
Yes, ma'am.
Very good. All right. So what is it? We have a right triangle. I'm not proceeding. I just want to, repeat this. So we have taken a right triangle ABC, right angle at B. We've marked this angle. This angle is X. So this is double X, which is 2X. Construction, produce CB to a point D such that CB is equal to DB. And then join AD. Join AD. Now we take up these two triangles and show that they are congruent to each other. Since this is 90, this is also 90, linear paraxium. You don't have to write all that. That's default, it's understood. So these two triangles are congruent by SAS rule. CPCT, we have one angle as 2X. We want another angle 2X. So since this is X, if you say that these two angles are equal by CPCT, then this also will be X. So the whole angle will be 2X. So angle DAC is equal to 2X. Also, we have to prove that the hypotenuse is equal to something, right? So we write another result by CPCT. The hypotenuse AC is equal to the hypotenuse AD. So that's till there we have understood. Till there, hopefully we have understood, all of us. So AC is equal to AD. AC is equal to AD. That's it. So now that you've done till here, the rest of it is easy. Now look at the whole triangle ADC. Look at the whole triangle ADC. ADC. Look at the whole triangle ADC. This angle is 2X. Now this angle is also 2X, which means in this triangle, the side opposite to 2X, this side is equal to the side opposite to 2X, this side. AD is equal to DC. ADC is an isosceles triangle. See, we have two right triangles. The whole triangle is an isosceles triangle. The whole triangle is an isosceles triangle. The whole triangle is an isosceles triangle. Take up the whole triangle ADC. The whole triangle ADC. We already have marked this angle as 2x. Now, after congruency and CPCT, we have this also as 2x. Now, in this triangle, two angles are equal. So the sides opposite to them are also equal. The side opposite to this angle is this one, DC. And opposite to this angle is this one, AC. AD. So AD is equal to DC. AD is equal to, am I reading it right? AD is equal to DC. Oh my God, again, another mistake I've made here, writing. AD, children. AD is equal to AC. Oh, I marked it incorrectly here. Okay, fine. Let me not confuse you. I said the hypotenuse is also equal. AC, hypotenuse AC is equal to the hypotenuse AD. I don't remember like what I wrote and said here. Forget it. Anyways, I'm saying the same thing. The hypotenuse AC is equal to the hypotenuse AD. The hypotenuse AC is equal to the hypotenuse AD CPCT. See, how did we get that? I just want to. This is the triangle, children, ADC. Yeah, I said this is 2x and this is also 2x. All right. Oh, I said something else, but I read something else. That's what I was wondering. What I blabbered. Okay. I said something that is here. What I said is here, but I was looking here at this on the screen. That's, yeah. Okay. I was talking about this point, but I read this one from the screen. All right. So what I was telling is this is 2x, this is 2x. So this side is equal to this side. AD is equal to DC. See here, AD is equal to DC. Sides opposite to equal angles are equal. This one, AD is equal to DC. AD is equal to DC. Sides opposite to equal angles are equal. Now this one also you have to write in CPCT. The hypotenuse AC is equal to the hypotenuse AD also you should write. Because we'll have to prove something regarding the hypotenuse, right? Hypotenuse is something. So write about the hypotenuse also. AC is equal to AD CPCT. CPCT. Okay. So in the whole triangle, since these two angles are 2x, this side is equal to this side. Sides opposite to equal angles are equal. Now we got it. Now what is AD? We have AD is equal to DC, children. We have AD is equal to DC. Okay. But AD is equal to what is DC? What is DC? DB plus BC. DB plus BC. See, we are going towards this result. What is the result? We have to prove that AC is equal to BC, right? AC is equal to BC. So we are heading towards this result. We have to prove that AC is equal to twice BC. So we are going towards this result. We're going towards this result using what? Using this one. Using this one. AD is equal to CD. Using AD is equal to CD. See, AD is equal to CD. Okay, using this, see, slowly using this, slowly we head towards this result. How? See it. AD is equal to what is CD? Look at the figure. What is CD? DB plus BC. DB plus BC or BC plus DB, whatever. Okay, so CD is nothing but DB plus BC. But these two are equal. No, we already know that by construction. DB is equal to BC by construction. So AD is equal to, we know that DB is equal to BC by construction. So instead of DB, we'll say BC itself plus BC. Plus BC. So we got AD is equal to twice BC. We got it. AD is equal to twice BC. But it's AD. But we should say AC is equal to twice BC. So that's why we wrote this. AC is equal to AD. AD is equal to AC. So now AD is nothing but AC. So AC is equal to twice BC. AC is equal to twice BC. So we have proved that the hypotenuse is twice the shortest side. You need to go through the proof once again, children. See, I've explained how it's fresh in your mind. By tomorrow, you must revise this proof. Then it will be registered. Then weekend again. Every time you revise, the time you need will, will not be the same as you took when you did it first. So first you would have taken half an hour. Then when you revise 15 minutes, then the third time you do hardly 5 minutes. That repetition is very important. Got it, children?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Good, children. Class, use the emoji. Raise your hand. Very good. Danya, Krishmika, Shri, Tanishka, Netra, and Madhumita. Very good. All right, children. So with this, we conclude this chapter, congruent triangles. We'll continue with Heron's formula. I'm sending another link, children, for Heron's formula. Please leave this meeting. I'll share another link. Join the meeting again using that link. All right?
Yes, ma'am.
Yeah. All right, children.
Yes.
Thank you. Yeah. Thank you. Please rejoin. Yeah. Using the other link. Thank you.